Hello everyone. So in this video we are going to talk about Docker. Docker. So what is a Docker? So Docker is just a tool or technology to manage containers. So in order to understand what is a Docker, first we need to understand what containers are. And if we understand well what containers are and what and how the problems containers solve, it will be easy for us to understand the Docker. Okay. So what is a container? So in a single line, I can say that it is a self-contained unit. Self-contained unit of what? Self-contained unit of softwares plus its code. Or if I break it down further, your source code plus all its dependency. So it is a self-contained unit of that. Let me give you an example. For example, I have an application and my application has some dependencies in it. Let's say four of them. So encapsulating all of that in a single unit, I can say that it is a container. It is a very plain definition of the container. So yeah, it is a definition. Self, why self-contained? Because all the dependencies are present inside it. It doesn't need to interact with the outside environment. Everything which I need to run this application is present inside the container only. That's why self-containing unit. Okay, we understand that key container is a self-contained unit and it contains source code with all its dependencies, whether it is libraries, packages, and runtime in itself. Okay, so why do we need? Now let's talk about why do we need containers, right? First of all, why do we need containers? So let's say, let us take one scenario. For example, and this is my local system, and I'm running one app in it, and it has some dependencies in it, some Python node we can see, and some package, and this all too will have some version. For example, I'm using Python 3, and I'm using Node also for some of the things, and using some version of the Node, and some packages is there, and that libraries is using, let's say, 6 version. Okay, and they are collectively utilizing and working to execute my app. Okay, now there is one scenario. If i want if i want to share my application, if I want to run this app in my, let's say, friend's system or my colleague system, what I have to do, I have to manually install each and every dependencies packages into my friends or my colleague systems. And then also there is no responsibility of that my app will run perfectly. Because for example, there might be a case, for example, my friend application has Python version of some Python installed, let's say 2.3 installed. So that will create a conflict. Okay, what I'm trying to say here, for example, if I have to run some application into some another system, my application dependency might create conflict with the dependencies present already on that system. So that, and that is a real case scenario. For example, doing a deployment, and you have to, first of all, what you have to do, you have to manually deploy each and everything into the your environment. And your environment might be using some of the dependencies of other versions, so that might create a conflict between the software, and there your you have to face some error there. Okay, so this kind of problem is solved by container. So how containers solve this problem? Let us go to our application. For example, our app need four dependencies. So what, I will create a container. So let us say this is our container, and we have already talked about containers are self-contained unit. They need not require external things. Everything which I need to run this app, I have in my container. So what I will do, I will pick this container and I will just directly execute it. Yeah, there are tools needed to run the containers, but we will talk about it later. We are just talking about the plain concept of the container for now. Okay, so what I have avoided, I have avoided this conflict. Yes, I have avoided this manual installation of the software onto the other system in which I have to test, run, deploy, staging, uh, everything. So this is the power of the container. This self-contained unit, it is running as it is running into my system. It will run into every system, regardless of anything, because whatever things my app need, it is inside container only. So that is the power of the container. And due to it, the deployment is easy. Managing dependencies is also becomes easy. You can scale your application. How so? For example, in my system there is a load, so I can scale horizontally. I can create lots of instances of my container. So the same application will now my server have lots of instance of that, so I can scale horizontally. Also, our containers are isolated. What does what does isolated means? For example, um, this is my system, and I have created container, and I'm trying to run this on my friend system. Okay, this is my friends, and this is the container. This is my container. Okay, let's say it just print hello world in Node. It is created in Node. It is just saying hello world in the browser. So all the dependencies are inside. Okay, so it will not conflict. It will not interact with my friend system. That is isolation. It will not interact with the resources which my it will work in a certain way that it is not going to interact with the dependencies on my friend system. That it works in isolation, the name suggests that. So these are the real world modern problem that containers solve. And Docker is a tool to create, manage containers, right? So how Docker works? So let us talk about that also. So let's say this is our operating system, and all the modern operating systems support Docker or have support for containers. For that, we have to turn some features on. For example, let's say in Microsoft Windows, we have to install some Windows subsystem for Linux and some Hyper-V. So that is second layer. On top of that, what we install Docker Engine, and on the top of Docker Engine handle all of the containers. For example, app 1, okay, its dependencies, app 2, its dependencies. So Docker Engine handle all of this, right? So this is how Docker works. So let me briefly talk about uh, what Docker Engine contains also. So if I talk about the architecture of the Docker Engine, so the very first thing we will look inside the Docker Engine is, so it has three main parts. First is Docker uh, daemon, right? And Docker daemon is responsible for managing objects. What objects? Docker objects. So what Docker objects do we have? Images, containers, volumes. These are all Docker objects. So Docker daemon is a kind of server of Docker, and it manages the Docker object. That is, it manages images, containers, volumes, everything, right? It also actively listen to the request which is made by Docker client. So the second thing Docker engine has is Docker client. So Docker follows client server architecture, and with the use of CLI, we can send request to the Docker server. For example, Docker run node. So this is a request. We can interact with the Docker daemon with using CLI. So it will It uses REST API to interact with the server. And yeah, also I've already talked. It is active. It is Docker daemon used to manage all the containers creation, deletion, stoppage, and everything. It monitors the container. The responsibility of Docker daemon is okay, and the responsibility of the Docker client is to send the request to the Docker server. Whatever I want. Okay, I want to run the container. Okay, it is sent via APIs, and it actively listens the requirement and does the job what is asked. Third, we have registry, like Docker Hub. So it is a centralized place where all the images lives. For example, I want Node application. I want Node in my system. So it is a centralized place from where I will fetch. Let us go back to our example. For example, I write docker run node command into my system, but my system doesn't have node. So what it will do? It will fetch it from this public repository, uh, Docker Hub, and it will then create a container, right? So these are three main components of the Docker engine, that is Docker daemon, and it is server which manages Docker objects, images, everything. Images, container, volume is it is managed by server only. It also actively listen to the request made by the Docker CLI or Docker client. Docker client is used CLI to interact with the Docker daemon. And lastly, we have a registry, that is Docker Hub, and which is used to interact, which is used to provide images. Okay, so this is the Docker engine in brief. So let me give a quick recap. We have seen Docker. Docker is a simple tool or technology for managing containers, right? And what is a container? Container is a self-contained unit. And what does self-contained unit means? It encapsulate application and your dependency into a single unit. And now that single unit is independent. Okay, whatever the requirement is there to run the application, it is there. And we have also seen why it is required and what problem does it solve. And yeah, this is the way Docker work. And Docker engine has three main units, that is Docker daemon, Docker client, and registry. I hope this is helpful for you. Thank you.